This video is going to review everything we did in 8.4, and 8.4 was all an introduction to logarithms. So I put some of the basic skills that you should have on the top of the screen that you're looking at. You should be able to evaluate basic logs, and we're going to review that cloud process. You should be able to switch from form to form, so going from exponential form to log form, or from log form to exponential form, and you should be able to write inverses. And the other piece that I'm going to show you is you also should be able to graph inverses, and some of the more, the honors classes may graph a little more challenging logarithms, and your regular level classes will graph a little bit more basic logarithms, but everyone should have an understanding of what a logarithm looks like. So we're going to start with just basic logarithms, remembering the crowd process. So I'm going to put that up at the top. So here was our basic logarithm idea. And you can use any letters, but the idea is when you have a logarithm that your base number to this power equals this value. So when you're evaluating a logarithm, you're actually giving the exponent. Your answer is an exponent. So when you look at the first one up here, when you're trying to figure out log base 3 of 81, what you really should be thinking is 3 to what power equals 81. And sometimes it helps to write it in that way so you see what you're trying to find. And you can do this by guess and check. You can go through by knowing some of your basic powers. You're going to get 4 because 3 to the 4th is 81. The next one, same idea. You're trying to figure out what power am I taking 49 to get 7. Now I'm getting smaller. So what you're doing, you want to think when I'm getting smaller, I'm probably taking a root, a square root, a cube root, something like that. It didn't become a fraction, so you're not really going to think negative exponents here. 49 to the square root of 49 is 7, so that is the 1/2 power. The next one, same idea. You're trying to figure out 5 to what power equals 1/25. When you see fractions occurring, you want to think negative exponents because that's what creates that fraction. It moves something to the bottom. So I am squaring it to get to 25, but I'm also taking it to a negative power to get it to the bottom. So my answer here is -2. And then my last one, I'm trying to figure out 1/3 to what power equals 9. So again, I went from a fraction to a whole number. So I must have used a negative exponent to kind of move the location. And I would take it to a second power because it needs to be squared. Now the next thing we're going to do is we're going to look at going from form to form, and it's the same idea with the cloud idea. The idea you're trying to switch from one form to the next. So the first two are starting in logarithm form and switching to exponential form. So you want to follow that cloud pattern. Sometimes it helps to just write it. So you would have 7 to the 3rd equals 343. And then the second one would be, now the base here is not written, so it's understood that there's a 10 there. Then you don't see that's called the common log. So it would be 10 to the -2 power equals 1/100th. The two logs that do not write the base are common log, which you'll just see the log with no number there, and then the natural log, and that has base e. The next one's going in the opposite order, so now we're going to switch from exponential form to log form. Keep in mind that your base number is still your base of your logarithm, so this is going to be log base 16. Your answer is your exponent, so it's going to be 1/4, and then your answer is going to be the exponent 1/2. And then going through this one, your base number A is going to be the base of your logarithm. Your answer is your exponent, so it's going to equal B, and then we're going to put a C there. Sometimes it's hard to think backwards, so you can always check your answer by doing that cloud process. For writing inverses, we have steps to write inverses. The variables need to be switched. We need to isolate the logarithm, and we need to do the cloud process. And then in the end, your answer should have y by itself again. You can do a lot of these steps in any order. The only thing that has to be done is you have to isolate the log before you do that cloud process. So that is the one part of the steps that cannot change the order. So some people like to change the variables first. Some people like to do the cloud process first. It's really up to you. With this one, if you just immediately go to the cloud process because the logarithm's already isolated, you would say 4 to the y equals x minus 7. And then switch the variables. So you'd have 4 to the x equals y minus 7. And if you did that in the opposite order, you would get the exact same thing. And then last step is get y by itself. So you get 4 to the x plus 7. And then the notation for inverse is just a little -1. So you could put y to the -1 or f of x with the -1. The next one, before you do any cloud process, you have to isolate the log. So you need to move 3 to both sides. So you have y plus 3 equals the natural log of x plus 1. Now if you want to switch the variables, I'll do this one in the opposite order just to show you it doesn't make a difference. X plus 3 equals the natural log of y plus 1. Do the cloud process. Remember that that is base e, so e to the x plus 3 power equals y plus 1, and then finally get y by itself. So your final answer is e to the x plus 3 minus 1 is equal to your inverse function. And the last thing you need to be able to do is work with these visually. So I tried to work with one that's not a common log or a natural log and then finish with one that is, so you get to see a kind of a tougher one and an easier one. The first thing you should be able to do no matter what the logarithm is identify the asymptote, the domain, and range, and you do not need a calculator for this. Your asymptote, you're looking at what you're taking the log of, and you're looking at what makes that 0. So my asymptote is just x equals 0. It will always be a vertical asymptote, and x equals. Don't let the minus 1 confuse you. It's not part of the log because it's not in parentheses. So I'm going to draw my asymptote right away. My domain is always going to be bigger than your asymptote. So it's going to be x greater than 0 because it's always on the right side of that vertical asymptote. And your range is always all real numbers for every logarithm function. Now you should have a decent idea of what this looks like because it is the inverse of your basic like 3 to the x function. But to be very specific, what we can do is we can write it in exponential form and come up with a table. So I'm going to add 1 to both sides. So I have y plus 1 equals log base 3 of x. Do the cloud, so 3 to the y plus 1 equals x. And then I'm going to make an xy table. But I'm going to choose y's instead of x's. So I'm going to choose y to be 0. Y to be negative 1, and y to be 1. If I put 0 in for y, I get 3 to the first, which is 3. If I put negative 1 in for y, I get 3 to the 0, which is 1. And if I put 1 in for y, I get 3 to the second, which is 9. So I'm going to graph these points on my graph. 3, 0, 1, negative 1, and 9. 1, 2, 6, 7, 8, 9, 1. And your graph should be really approaching that vertical asymptote, getting very, very close to it. When you try to graph a lot of logarithms on your calculator, the common logs and natural logs, it makes it look like the graph just stops. This graph doesn't stop. It continues to go down and get closer and closer to the vertical asymptote. And then finally, the last one. This one you could definitely do on your calculator, but we're going to talk about some of the things that you don't need a calculator for. Your asymptote is at x equals negative 3. Because your graph has shifted over 3 places to the left. It's the idea of what makes that natural log 0. So I'm going to put my vertical asymptote right here. My domain is x is bigger than negative 3 because my graph will always be on the right side of the asymptote. My domain is all real numbers. If I want to graph this on my calculator, I don't need to take a lot of steps to graph it. I can just use my natural log button. I almost have that there. I'm going to change it slightly. So I have the natural log of x plus 3 plus 1. Is that a minus 1? Minus 1. Hit graph. You can see the asymptote, and here's what I mean by the calculator kind of making it look like it stops. It does not stop. It just gets closer and closer to the asymptote, so you can draw something with this general shape. And that is everything in 8.4. It's a pretty long section. You should be able to evaluate basic logs. Should be able to rewrite in different forms, find inverses, and then graph logarithms.